Good morning, this is Traptika. Today I'll be explaining experiment number 7, which is all about linked list. So we'll be seeing the application of that and how it is being used in Python programming language. According to one particular question, we'll be seeing that. Okay, let's get into it. So firstly, let me share the code. Okay, so let's see the code first. So I'll be explaining it, why we have used and all that. So firstly, let's see what singly list is all about. So singly linked list is actually a linear data structure, which where each element is called a node. So each and every element in singly linked list or in a linear, which is a type of linear data, it will be called as node. So these nodes will have two kind of parts in it, data part and next part into it. So now let's get into the code, like how it gets executed, all that. Before that, let me tell an example so that like it's easy to understand the concept of singly linked list. So if we have three nodes, for example, if we have three nodes 10, 20 and 30, they'll be linked like 10. Next, like first data would be preferred, and then next their address would be specified, and then followed by the data 20 would be specified, followed by um, followed by 20, the next address next would be specified, and then the data 30 would be specified, followed by none, which shows there is no such no which is the last particular data which is specified in the whole node. So first node would be 10, second node would be 20, and then third node would be 30. So if there is no next node in the upcoming element of element or data of the node, it would be specified as none. So this is the concept behind single linked list. So now let's see how the execution happens. So now first we'll be creating a node class that would hold the value of that would hold data along with the values. So data is nothing but, for example, when I told 10, 20, 30, these are the datas that a node could hold. And then it will hold a pointer called next to it, and then next, initially next is set to be none, and then followed by that we create a class called linked list. So linked list is used to manage these nodes, which would manage each node being specified in the whole code. So head is the first node in the linked list. Head, if at all head is none, it means the list is empty. So first we create an empty node, and then we'll be initializing it. Sorry, then we'll be moving ahead. So first, nextly, the operations would be performed. Operations like no, inserting a node at the beginning, inserting the node at the end, and at the specified position. So these are the operations that we are going to uh, no, do it, like execute in the code, and then a deletion would be performed, just the way insertion happens at the beginning and the specified position. Same way deletion will be happened at the beginning and the specified position. So we use some print functions in this linked list so that the nodes, the data values would be finally printed out. So first, the stack will be, we use the stack in order to use a linked list. So the stack is a data structure that follows a LIFO principle, as we know, last in and first out policy, which means last element would be added and the first element would be removed. So first push operation would be performed, then pop operation. So first we'll be pushing the data 10 into the stack, and then 20, and then 30. So the stack will be filled from top, I'm telling. So from the top, 30, 20, 10. So this is how the stack would look like. And then if we want, we'll be removing 30, because the top element only could be removed from the stack always. Performing queue into this linked list, we'll be using FIFO policy. So first in, first out is the policy, that is the principle, sorry, that we use in queue. So for that, there are two pointers that we use, front and rear pointers. Rear pointer. So front is a pointer that points at the first node, and rear is a pointer that points to the last node. So here we perform two main operations like NQ and DQ. NQ would add element at the rear point, and whereas DQ would remove specific element from the rear point. And then just like we performed in stack, we'll be NQing and DQing the elements or the data 10, 20, and 30 in the way we did in the stack. So likewise, we'll be performing the same thing in queue also, like NQ of 10, NQ of 20, NQ of 30. So the front will be like 10, 20, 30 followed by none. And then to perform DQ, element 10 would be removed first. As we know, FIFO policy will be applicable. So this is how the code gets executed, and we'll have to check whether the linked list is empty or not. So to check whether it is empty or not, if the head is none, it means the linked list is empty. So we'll have to check if at all the linked list is empty. We'll have to check if head is none or not. So now let's see how the execution happens, so that we could understand it in a better way. Let me show it. Okay. So this is the code. As I said earlier, we'll be creating a class called node, then a class called linked list followed by it. We are checking if at all the node is empty or not. And then we are trying to insert element at the beginning. We'll be trying to insert it at the end and at the specified position. So insertion is done as of now. After the insertion, deletion. So deleting at the beginning, deleting at the end, and deleting at the specified position will be done. So insertion and deletion is according to the stack we have seen. So next we'll also be doing search thing. So because if at all we'll have to search a specific data into the particular node, we can search it through search of self comma value, so that we'll be able to search a specified data from the node. If at all I need to search data number data number 10, I can use this logic. So after searching, I'll obviously have to display it. So display would be like this. I'll be displaying, and then in the class called stack, in stack operation, we'll be initializing the node first, and followed by that, we'll be pushing element or pushing the data into the stack, pop, removing it, and then display. So this will be done after that queue. Queue operations, as we have discussed earlier, NQ operation would be happening first, followed by that DQ operation would happen, and then as usual we'll be displaying the element or displaying the data from the node, and then we'll be using we'll be performing list of operations, so that that becomes easier accessing the element that we have created. So we'll be printing each and everything, each and every time NQ, every time DQ happens, every time push and pop happens. So this is how it executes. So now let's see how it runs. So yeah, so this is how it runs. So let's see. Okay, so first it lists out the operations. 10 is inserted first, 20 is inserted, then 30 is inserted. Followed by that, so now the linked list will look like this. As I told, as there is no further element attached next to it, it looks like none. And then 5 is inserted, 25 I'm inserting at the position number 3. So the linked list would look like this. If I have to find 20, if I really find it in the list, it would show found in the list. If I have to delete, 30 would be deleted, and stack operation push 10, push 20. So all that push operations will happen. So this is how top to bottom the linked list was, sorry, the stack would look like. If I pop 30, and then the stack would look like this. After the queue operations, enqueuing elements would look like 10, 20, and 30, followed by DQ. If I DQ the element number 10, data number 10, finally, from front to rear, my queue will look like this. So this is how the execution happens. Uh, okay, so thanks for watching. So the execution of how linked lists that can be used along with push pop operations and NQ and DQ is being demonstrated in this particular exercise for the better understanding. Thank you.